Hello Cashmaticians! This is the second part in my series on differentiating trigonometric functions. If you haven't seen the first part, please watch that first because we'll be using some standard results which I've proved in that video. In this lesson we'll be looking at using those results to differentiate functions of those functions, as well as showing you how to apply them using the chain rule, product rule and quotient rule. So if you don't know how those work, please watch those videos first. So as always, grab yourself some paper and a pen and let's do some maths. The results you can see on the screen are the results from the last video, and some of these results you'll find in the differentiation section in your formula books, and the others you might find in the integration section. But make sure you know where they are in your formula book, okay? And they differ from syllabus to syllabus, all right, and exam board to exam board. So make sure you're not wasting time looking for them. Get familiar with your formula book so you know exactly where to find them. Now, don't worry if you can't see them when I do my examples, because I am actually going to put them on the screen, okay? So you don't need to write these down just yet, but make sure you know where to find them when you need them. Right, the first lot of examples we're going to do are going to require us to use the chain rule, okay? The derivatives are going to look very similar to what we've got on the left. The things we have to differentiate are going to look similar to what we have on the left, but they're not going to be exactly that, and I'll show you what I mean. So the first one, for example, if I said y equals tan 3x, okay, we know that tan turns to sec squared, okay, so tan turns to sec squared, so dy by dx will equal sec squared 3x, okay, because it's not an x, it's 3x. But then I have to remember to multiply by the derivative of the inner function, okay, this is how the chain rule works. So the whole function goes 3x and then we take the tan. So we have to differentiate the tan first and then differentiate the 3x. And the derivative of 3x is 3. So the whole thing is 3 sec squared 3x. And similarly with this example, we've got a function inside a function. So the order of the functions is this. We've got 4x and then we take the sec. Okay, so we have to differentiate the sec first and then the 4x. So dy by dx equals the derivative of sec, which from here you can see is sec x tan x. But in this case, it's going to be sec 4x tan 4x, and then I multiply by the derivative of 4x, which is 4. Okay, so overall we've got 4 sec 4x tan 4x. Okay, now having done those two examples, pause the video and try this one for yourself. Okay, and hopefully you've had time to do that. Right, so let's see what we've got. We've got 5x, okay, and then we take the cot of that and then multiply it by 3. Now the 3 doesn't really make a difference in terms of the functions, we just need to make sure we multiply the whole thing by 3. Okay, so dy by dx will equal, now cot becomes minus cos x squared x, but we've got this 3 as well, so it's minus 3 cos x squared, now it's 5x because that's the angle, multiplied by 5. Okay, because that's the derivative of 5x. So overall, we've got minus 15 cos x squared 5x. Okay, and one more like that. You can pause the video and give it a go, and then I'll do the answer shortly. Right, so the answer, let's have a look what we've got. We've got x cubed, that's the inside function, then outside of that we've got cos. Okay, we're doing the cosine of x cubed. So the first thing we differentiate is cos, okay, and cos becomes minus sine, so it'll be minus sine of x cubed multiplied by the derivative of x cubed, which is 3x squared. So let's tidy that up. That would be minus 3x squared sine x cubed. Okay, let's have a look at this one then. Now we've got 3 functions here. We've got x being multiplied by 4, and then we're taking the sine of that function and then we're cubing it. Now the way I like to think about it is like this. Ultimately we've got something cubed, okay, and that is the sine of something, and that something is 4x. Okay, so what I do is I differentiate each of these. So these will be 3 something squared, okay, this one here will be cos of something, and this one here will be 4. So ultimately what we're doing is we're going to work out these derivatives and multiply them together. So I'll show you what I mean. Okay, so dy by dx equals sine cubed. Okay, so that's something cubed becomes 3 something squared. Okay, so that's 3 something squared. Okay, now we have to deal with the sine. The sine becomes cos, so that'd be cos 4x, and then we have to multiply by 4. Okay, sorry, this is getting a bit untidy. So remember, it stops here. So what we've got is 12 sine squared 4x cos 4x. Okay, so if you need to, pause the video and look through that again, and then I'll put up one for you to try. Okay, so here we've got 2 tan to the power 5 of x cubed. Don't worry about the 2 just for now, we just need to make sure the whole thing's multiplied by 2. But think of the order of the operations and how you can differentiate using the chain rule without having to write down the whole chain rule business. Okay, so pause the video and I'll go through it in a bit. Okay, so here we go. All right, so if you think about it, we've got x cubed, and then we take the tan of that, and then we do it to the power 5. I'm ignoring the 2 for now. Okay, so basically, we've got something to the power 5, and this something is the tan of something, and this something inside is x cubed. Okay, so it's a function of a function of a function. So this here becomes 5 something to the power 4. This here becomes sec squared of whatever the something is, and here we've got 3x squared. Okay, let's put all that together. So dy by dx, now I'm going to keep the 2 there. Okay, so 2 multiplied by 5 tan to the power 4 of x cubed multiplied by sec squared of x cubed multiplied by 3x squared. Okay, now that does look horrible, but let's put it all together. So 2 times 5 is 10, times 3 is 15. So 15x squared, so I'm writing this x squared first. Then I've got tan to the power 4 of x cubed sec squared of x cubed. Okay, that was a bit of a tough one, and if you got that right, well done. Okay, now we'll do 1 or 2 of these inverse trig functions as well. So y equals the inverse tan of 3x. So dy by dx, now we've got to be careful here. Now inverse tan becomes 1 over 1 plus x squared. Okay, but instead of x, I've actually got 3x. So my x squared is going to be 9x squared. So that would be 1 over 1 plus this squared, so 9x squared, multiplied by the derivative of this, which is 3. So overall, I've got 3 over 1 plus 9x squared. Okay, and I'll do 1 more of those. Okay, like before, just ignore the 3. We can deal with the 3 quite easily. Inverse cos becomes minus 1 over the square root of 1 minus x squared. But instead of x, I've got 2x cubed, so that's what I need to square when it comes to this part here. And then I need to multiply by the derivative of 2x cubed. So what we get is dy by dx equals, now minus because of this minus here, 3 because of this 3 here. Now inverse cos becomes 1 over the square root of 1 minus x squared, but instead of x, I've got 2x cubed. If I square that, I'll get 4x to the power 6, and then I have to multiply by the derivative of this inside function. So the derivative of 2x cubed is 6x squared. Okay, so let's put all of that together. I'll get minus 18x squared on the top over the square root of 1 minus 4x to the power 6. Right, so moving on to some product rule questions. So if you remember, the product rule goes d by dx of uv is u dv plus v du. Now it doesn't matter which one we pick to pick u, which one we pick for v, that doesn't make a difference. So I'm going to say let x squared equal u, okay, and let v equal the cosine of 3x. So du, so the derivative of this is just 2x, and dv, the derivative of cos 3x would be minus sine 3x multiplied by 3. Okay, so just like we did in the last few examples, so that would be minus 3 sine 3x. And all we need to do now is just put it all together. So dy by dx is equal to u dv, So this one multiplied by this one, okay, so that would be minus 3x squared sine 3x plus v du, that's these two multiplied together, so plus 2x cos 3x. And you know, if you wanted to factorize out an x, you could do so, but I'm not going to bother with that just yet. Right, so here's another with the product rule. So u equals ln x and v equals cot 3x. So du, so ln x becomes 1 over x, and dv cot becomes minus cos x squared, so that would be minus 3 cos x squared 3x. So hopefully you understand why I multiplied by 3, and that was because of the derivative of 3x. So we just need to put it all together. dy by dx is equal to u dv, so these two multiplied together, so it'd be minus 3 ln x cosec squared 3x plus these two multiplied together, which would be cot 3x over x. And one last one. Now this one will be a little bit trickier because I've got the inverse tan function as well, so let's just take our time with this. I'm going to give myself a little bit more room, so I'm just going to put u and v over here. So u equals x squared and v equals the inverse tan of 5x. Now du is straightforward enough, that's just going to be 2x, and dv, so inverse tan becomes 1 over 1 plus x squared, so that would be 1 over 1 plus, but I haven't got x, I've got 5x, so that would be 25x squared multiplied by the derivative of this, which is 5. I'm just going to tidy all that up. That's 5 over 1 plus 25x squared. Right, so let's put all that together. dy by dx equals, so u dv, so this multiplied by this, so that would be 5x squared over 1 plus 25x squared, add u dv, that's these two multiplied together, so that would be 2x inverse tan 5x. Right, and finally we've got some quotient rule examples. Now remember, with these it is important which one is u and which one is v. Remember, the numerator has to be u and the denominator has to be v. Okay, so let's just give ourselves a bit of room here. So we got u is equal to sec squared x, okay, and v is equal to x. Now this one is actually a little bit tricky, alright? If u is sec squared x, now remember this is a function of a function, okay, because I haven't got sec squared on this side here, alright, so I need to look at the derivative of something squared, so du would be 2 sec x multiplied by the derivative of sec x, which is sec x tan x, okay, so overall that would be 2 sec squared x tan x, okay, and dv, that's a nice easy one, that would just be 1. Alright, so let's put all of that together, but let's just take our time with it. dy by dx equals v, which is x, then du, which is 2 sec squared x tan x, minus u dv, so u, which is sec squared x, and dv is just 1, so I don't need to do anything there, divided by v squared, which is just x squared. And if you wanted to tidy that up, I suppose you'd write this as 2x, okay, and the sec squared I suppose you could factorize out, so let's just do that. Sec squared x, okay, got that in the top in both terms, okay, and then I'd multiply by 2x tan x for the first term and minus 1 for the next term, all divided by x squared. Okay, so let's try this one as well. Remember, u is the top one, so u is ln x, and v is equal to cot x. So du would equal 1 over x, and dv would equal the derivative of cot x, which is minus cosec squared x. Alright, so let's put it all together. dy by dx equals, alright, so v du, so cot x multiplied by 1 over x, so 1 over x cot x, take away u dv, so ln x multiplied by minus cos x squared x, okay, we'll sort the signs out afterwards, divided by cot squared x. Okay, so let's tidy all of that up. So the top term becomes cot x over x plus, because I've got two minuses here, ln x cos x squared x, all divided by cot squared x. And that looks a bit horrible, so what I'd probably do is multiply the top and the bottom by x. So that would cancel out the x from this term, so that would give me cot x plus x ln x cos x squared x, all divided by x cot squared x. Okay, and one last example. Okay, this one looks a bit nasty, but let's just see where we go with it. Right, so u is equal to e to the tan x and v is equal to cos x. Let's do the easy one first. So cos x is easy, that becomes minus sin x, but du, now e to the something just becomes e to the something, but then I have to remember to multiply by the derivative of that something, which is sec squared x. Okay, so I'm going to write that as, yeah, actually let's leave it like that, that's fine. Okay, right, so dy by dx, let's have a look. Alright, so v du, so cos x times by e to the tan x sec squared x. Now there is some simplification we can do there, but let's just write it as it is for now. So cos x multiplied by e to the tan x sec squared x, take away u dv, so e to the tan x minus sin x, sorry, we'll sort the signs out afterwards, divided by cos squared x. So I did say we can simplify this first term, right? So because sec squared x is 1 over cos x, right? So this here, well, sec squared x is 1 over cos squared x. This cos x is going to cancel with one of these cos x's and leave me with just sec x. So the top term there just becomes e to the tan x sec x, take away, well, this is going to be a plus actually because it's got a minus here and a minus here, e to the tan x sin x, all divided by cos squared x. And in an exam I'd probably be tempted to factorize out the e to the tan x, so e to the tan x, then open brackets sec x plus sin x, all divided by cos squared x. Right, and there you go. Right, so I've given you plenty of examples there, and hopefully you understand the whole process. If you want to, what you could do is you could just go back and pause the video at the start of each example and give it a go yourselves and see if you get it right. And yeah, if you've understood that, that's brilliant, and hopefully I'll see you next time. Goodbye for now.